so hey, we're going to talk about solving radical equations. So remember that radicals and rational exponents are kind of interchangeable. So our first step is going to be to isolate the radical or that parentheses that has that rational exponent term. So you want to get that by itself. Now something we also need to keep in mind is that, remember, if you take a square root, then that means you're going to have plus or minus answers. So you're going to have two answers. Now, we've been working with more than just square roots. So that means if you end up taking a fourth root or you end up taking a sixth root, okay, so any even root is going to mean that you have two answers. Now, this is only if you take the root, okay? That means we are taking the square root of something. So just keep that in mind. I'll bring that back in a few. All right, so here we go. Example 1. We're going to go ahead and solve this. The first thing we want to do is we want to look and we want to get this radical term by itself. So you can kind of see there's nothing extra being added or subtracted here. So this radical is already by itself. So I have to get rid of this third root. So I have this third root, which means that I am going to take a third power. So I'm going to take each side to the third power so that they match. So a third power and a third root, those undo each other. And now I'm going to be left with just 2x plus 7. And 3 to the third power is going to be 27. So now I have this simple equation to solve. So I subtract 7 from each side, and then I can go ahead and divide by 2, and I can see that x is 10. All right, let's check out example B. That one was pretty easy. This one, same idea, okay? But now notice that I have this 4 and I have this plus 1. So I have to get this radical by itself. This one was already isolated, so I didn't have to do any pre-moving. This one, I've got to get this by itself. First thing I'm going to do is I'm going to subtract this 1. Now this is 4 times the square root. This is not the fourth root, so be careful with that. And now this is 4 times, so I'm going to divide by 4 to get rid of that. So I have the square root of x minus 3 equals 6. Now this is the square root, so to undo a square root, that means I'm going to have to square each side. Okay, so a square root and a squaring, those cancel each other out, and I'm left with just x minus 3. And 6 to the second power is 36. So go ahead and finish solving this by adding 3. So now I get that x is 39. So although I started with a square root, okay, I didn't take a square root, so I'm not having to worry about any sort of plus or minus. All right, let's check out this example C, where now I have this rational exponent. So it's the same idea, but I still have to get this x plus 2 term by itself. I have to get this piece by itself. So I'm going to have to go ahead and move over this 1 first. So now I'll have x plus 2 to the 3/4 power equals 8. So I have to get rid of this exponent. So if you think about properties of exponents, if you take a power to a power, if I put an exponent here, what do? Well, a power to a power, you multiply. So if I choose to multiply by the reciprocal, so if I have 3 over 4, my reciprocal is going to be 4 over 3. So if I multiply by the reciprocal, think about what's going to happen here. I'm going to have 3 times 4, which is 12, and 4 times 3, which is 12. So I'm going to end up with an exponent of just 1. So over here, I'm also going to do the 4/3 power. Okay, so let's really understand what's happening here. This becomes x plus 2 to the 12 over 12 power. So that ends up canceling out. And here I have 8 to the 4/3 power. Now, you can go ahead and type that into your calculator if you want, but you have to be very careful because you have to look for an even index, all right? The index is the denominator. I think it's always helpful if you change this into a radical. If I change this into the cube root of 8 to the 4th power, and then all of this is just x plus 2. Now, the reason why I would change this into a radical is so I can really see that I have an odd index. So I don't have to worry about any sort of plus or minus, okay? We are the ones that put this 4/3 on the paper, so we're the ones that are taking the cube root. Now, if I'm taking a 4th root, then I have to worry about plus or minus. So if you don't have this on your paper, if you don't change that to like radical form, you might miss the fact that there could potentially be a plus or minus. So here, now I evaluate this. I have x plus 2, The cube root of 8 is 2, and I still have that to the 4th power. Put that in parentheses in case it was negative. So now I have x plus 2 equals 2 to the 4th, which is 16. So we can subtract 2 and get that x equals 14. And we only have that one answer there. All right, last one of this type. So we're still going to go ahead and get this by itself by subtracting my 3. So 2 times x plus 2 to the 2/3 equals 8. Now do not distribute. That's terrible, terrible, terrible math. Go ahead and divide by 2 on each side. Now I have x plus 2, and it's still to the 2/3 power, equals 4. So thinking like we did in the last problem, if I need to take this to some power, I'm going to take it to the 3/2 power. And I'm choosing 3/2 because that's the reciprocal of what I have. And if I multiply my power to a power, 2/3 times 3/2, they end up becoming 1. So my power is gone. It cancels out. So I'm going to do the same thing over here. So now those cancel out, and I have x plus 2. Now over here, what we need to see is that this 2 right here, that's my index. And it's even. Okay, so you need to pay attention for that. Now, if you don't want to pay attention for that, if you don't see that, you can always change it into a radical. This is going to be the square root of 4 to the 3rd power. So again, even index, which means we're going to have a plus or minus. So we took the square root. See how the square root was not originally in my problem? I took the square root because I have that 3/2 power. So when I take the square root of 4, I have to end up with plus or minus 2 to the 3rd power. So now I have two separate problems to solve. I have to solve x plus 2 equals 2 to the 3rd power, and I have x plus 2 equals negative 2 to the 3rd power. So I have x plus 2 equals 8, which means x equals 6. And then I have x plus 2 equals negative 8, which means x equals negative 10. So I have two answers here, and I have those two answers because I took that square root. I had that even index. All right, great job. This is level 1. We've got kind of 3 levels of problems here, so we'll check out the next in a few.